How many group homomorphism are there from Z to S5? Now, suppose F is a homomorphism and domain is Z2, codomain is S5. So we have to seek which number exists for such homomorphism. By fundamental theorem of homomorphism, which says domain, D for domain, and for normal subgroup of domain, this is isomorphic to F of D, means domain elements, and this is subset of codomain. So subset of codomain is 5. For Z2, there are two normal subgroups. One is Z1, another is Z2 itself. These two are the only normal subgroup. Z1, it means trivial, and Z2 having elements 0, 1. So this is the structure. By fundamental theorem of homomorphism, we can say Z2 upon Z1. This is isomorphic to Z2, and Z2 is subgroup of S5. So Z2 is a subgroup of S5. So our target is how many subgroup? This is subgroup of order 2. Order 2. So this is finite and cyclic. So how many cyclic subgroup of order 2 exist in S5? So we are seeking how many subgroups. So number of subgroups of order 2, how we calculated? This is the formula. Number of elements of order 2 in S5 upon value of phi 2. Value of phi 2 is 1. So only we have to seek number of elements of order 2 in S5. So partition of 5 as 3 plus 2, but LCM is not 2. LCM is not 2. So we will not calculated this one. When partition is 2 plus 2 plus 1, then LCM is 1. So elements of order 2 exist regarding this partition. And when partition is 2 plus 1 plus 1 plus 1, then again LCM is 2. So 2 order element exist. So how to calculate elements of order 2 regarding this partition? So factorial 5 upon 2 raised to the power 2 factorial 2 into 1. Now cycle of length 1. 1 raised to the power 1 into factorial 1. After simplify this expression, we will get 15, and regarding second partition, factorial 5 upon 2 raised to the power 1 factorial 1 into 1 cube into factorial 3. Simplify this one, we will get 10. It means total 25. Total 25 elements. Total 25 elements of order 2. Elements of order 2 in S5. When normal subgroup is Z1. When normal subgroup is Z2, then using fundamental theorem of homomorphism, Z2 upon Z2 is nothing but identity or trivial subgroup. So Z1 is a subgroup of S5. Means you have to seek only a cyclic subgroup of order 1. So this is trivial. So one homomorphism regarding this one and 25 homomorphism regarding, as I already explained above one. So total 26 homomorphism exist. Now this is the mathematical structure. If you know some relevant higher mathematics regarding homomorphism. Now come to very basic knowledge of mathematics and we can solve this problem efficiently. For this, you have to remember only two facts. One fact is identity will go to identity, means this is the identity of domain, and second one is identity of codomain. Now order of image always divide order of input, means order of output always divides order of input. So mapping, or we have to seek homomorphism from Z to S5. Z2 elements are 0 and 1. Elements 0 is identity, so order 1, and order of 1 is 2. In Z5, we already calculated there are 25 elements of order 2. Suppose element A, B, C up to and so on. These are elements of order 25. So how homomorphism look like? Let's say this is Z2 and this is S5. So 0 is going to identity. Identity maps to identity. Now this is element 1. So element, suppose, going to A, and other elements is remaining same, remaining left. These other elements are not pre-imaged by someone because only there are two elements in domain. Now this is one homomorphism. This is another homomorphism I am arranging or mapping. So identity to identity, and one is going to another element of order 2, and other elements like A, C, D and so on is remains left. These are not mapped by someone. So this is another homomorphism. So you can check that we have 25 possibility regarding 1. 1 may, because order of 1 is 2 and there are 25 elements of order 2. So 1 by 1 in 1 arrangement you can take A with 1, B with 1, C with 1. So look like this, we can arrange in 25 ways. So 25 homomorphism regarding this when 1 is going to order 2 elements. So there are 25 homomorphism and one homomorphism is trivial. So trivial homomorphism look like this. We have two elements in domain and there are many elements in a S5, but this is identity. So all element is going to identity. This is trivial homomorphism. And you can check that this is satisfying this result. Means order of output, this is output, always divides order of input. So order of 0 and order of 1. So order of 0 is, because 0 is identity element, is 1 and order of 1 is 2 and this is identity. So 1 divides 1 and 1 divides 2. So this is also perfect. So you can feel how we are arranging homomorphism. So there are 26 homomorphism from Z2 to S5. Option B is right one.